What we're talking about today is Lesson 89, Identifying Characteristics of Quadratic Functions. The vertex of a parabola is the highest or lowest point on a parabola. It is the parabola's turning point. Okay? The minimum of a function is the least possible value of a function, and the maximum of a function is the greatest possible value of a function. It is the y value of the lowest or highest point on the graph of a function. On a parabola, the minimum or maximum is the y-coordinate of the vertex. Okay, so that's important for you to know. The minimum or maximum is the y-coordinate of the vertex. So, for example, so identifying the vertex and the minimum or maximum. Give the coordinates of each parabola's vertex, then give the minimum or maximum value and the domain and range of the function. So first of all, it said that the vertex is the parabola's turning point. So if I look at A and I follow the parabola, I'm going down, 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 down until I get to here, then I start going up, 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 up. So this is the turning point right here. This is the vertex. This point, notice it's going by twos. This is -2, 4, 6, 8. Okay, so this is down 2 on the y. It's not over at all on x, so it's going to be 0. And then, not 2, 4, because it's going by twos, -2, -4. So this is the vertex, okay? And in this case, we're not going to have a maximum, but instead we're going to have a minimum, because this is the low point, right? Everything else is above that. So the max is going to be the y, which is x, y, so -4. I just said there's not going to be a maximum. It's the minimum, okay? So that's going to be that -4, okay, because it's the lowest value it can have. And then it wants to know the domain and the range. Okay, so the domain, remember domain is x and range is y. Okay, so for the domain, it's getting wider in both directions. So the domain would be all reals. And the range has a minimum at -4 and everything else is above that. So for the range, we know we're talking about y, okay, and -4 is our minimum. Everything has to be, it can be equal to that, so I can put an equal sign, but y has to be greater than or equal to -4. Final answer. So what I want you to do now is I want you to try and find all of those things for B on your own, and I want you to pause the video so they have a chance to do that. Please pause now. On B, the vertex, remember, is the turning point. So if I start here, I'm going up, 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 up until I get to here, and then I'm starting to go down. So this is the turning point, or my vertex. Okay, and I have to have x and y because it has to be an ordered pair. Again, it's going by 2, so my x is 2. My y, it looks like, is between 4 and 6, so it has to be 5. Okay, so that's my vertex. The next thing I need to know is my minimum or my maximum. In this case, we have a high point. Okay, so we're going to have a maximum. And the maximum is going to be the y value. So the max is y equals 5. Then we need to know the domain and the range. So again, domain is x. Range is y. Okay, so the domain on this one, it's getting wider in both directions. So the domain, again, is going to be all reals. And the range is going to be y, and it has to be 5 or less because it's going down from 5, okay? So it has to be equal to or less than 5. Final answer. Intercepts, zeros, and roots are related. An x-intercept of a function is the x-coordinate of the point where the graph of the equation intersects the x-axis. A zero of a function is the value of x that makes f of x equal to 0 or y equal to 0. Remember that f of x and y mean the same thing. Okay? Because y equals 0 for every value of x on the x-axis, the zeros of a function are the same as the x-intercepts. So if it asks you to find the zeros, the intercepts, or the roots, it's wanting you to tell the points where the graph hits the x-axis. So, for example, on 2, it says find the zeros of the function. The x-axis is right here, right? So where it hits the x-axis, this is the graph, it's going to be here and here. Okay? So my x value here, if this is -2, x is equal to -1. And over here, I'm over 1, 2, 3, x is equal to 3. Those are my zeros. And I could check that by plugging them in to this equation. And if whenever I plug in -1, I should get 0 for f of x. If I plug in 3, I should get 0 for f of x. We're going to do the same thing on B and C. Okay, so on B, our x-axis is right here. Pretend like I made it. There we go. Okay, so it hits the x-axis right here, just at one point. So on this one, my 0 is going to be at x equals -2. Okay, final answer. On C, my x-axis is right here. Pretend like that's a nice straight line, even though it's not. On this one, my graph is up here, right? Does it hit the x-axis? No, it doesn't hit the x-axis. And if it doesn't hit the x-axis, there are no zeros. Okay? An axis of symmetry is a line that divides a figure or graph into two mirror image halves. All parabolas have an All parabolas have an axis of symmetry that passes through the vertex of the parabola. In the figure, notice that the equation of the axis of symmetry includes the x-coordinate of the vertex, 2. Also notice that 2 is the average of the zeros 1 and 3. What they're saying is the vertex is right here, okay, and x is 2, that's this line right here. Well, it's a straight line though, okay. That's where I could fold this right over and put it on this side of the graph and it'd be a mirror image of it, right? They also said if it doesn't come out where you can see it really easily that it's 2, you could average the x's. So my first x is 1, my second x is 3, and if I'm averaging two numbers, I have to add them and divide by 2. So I get 4 over 2, which is just equal to 2. So it's the same thing. For example, it says find the axis of symmetry for each graph. Well, on the first one, it gives me my vertex, which means I just have to use the x value. So I know that the axis of symmetry is that x is equal to -4.5. Because I would go to -4.5 and I would draw that dotted line showing that I could fold that graph over and have a mirror image there. On B, that's not as easy. They don't just give us the vertex. It looks like it's about right here. Okay, but we can know for sure by averaging. So I'm going to take -3 plus 5, those are my two x values, and then I'm going to divide them by 2, because if I average two numbers, I add and divide by 2. So -3 plus 5 is 2 over 2 equals 1, so it would be x is equal to 1. So, looks like about right here. Whoops, that'll work. Okay, there is my axis of symmetry. Axis of symmetry can also be found by using a formula. The axis of symmetry for a graph of a quadratic equation y equals ax squared plus bx plus c, okay, where my coefficients are a, b, and c, is x equals the opposite of b over 2a. So you take this one, the opposite, so if it's a positive, you turn it to a negative. If it's a negative, you turn it to a positive, and then 2 times a. So, for example, wants us to find the axis of symmetry for the graph of each quadratic function. I know that I have to use a, b, c. A doesn't have a coefficient here, but I should remember that it's an understood 1. Okay, we just said we can find it by taking the opposite of b over 2a, which is going to be -6, which is b, over 2, and instead of a, I put 1. So I have -6 over 2 gives me -3. Okay, so that is going to be my axis of symmetry. X is equal to -3. On the next one, same thing. I'm going to use my opposite of b over 2, that's a b, not a 6, b over 2a. So b is 3, so I'm going to have negative 3 over 2, and instead of a I'm going to put negative 2. So I have negative 3 over negative 4, which just gives me 3/4. Okay, so I have x is equal to 3/4. Okay, and that is my final answer. Example 5, last example, says a golf ball is hit from an elevated platform 10 feet above the ground. It starts with a vertical speed of 160 feet per second. Ignoring friction, the equation y equals negative 16t squared plus 160t plus 10 gives the height y as a function of time t. Find the highest point the ball reaches and how long it takes to reach it. Okay, so on this, what we're going to do is we're going to start by finding our axis of symmetry. Okay, so I have the opposite of b over 2a, and remember we have a, b, c, so negative 160 over 2 times negative 16, so I have negative 160 over, and then 2 times negative 16 is negative 32. I don't have my calculator, so I'm going to cheat and use the book. That gives me 5. Okay, so what we're going to do with 5 then is we're going to use that and substitute it for t. Okay, so I have y equals negative 16 5 squared plus 160 times 5 plus 10. Okay, so whenever I simplify this, I have y equals negative 16 times 25 plus, we'll just write it like they have it, 160 times 5 plus 10, which gives me that y is equal to 410. Okay, so this was my axis of symmetry, which is x equals, right? So that gives me my ordered pair, x, y. So I have 5 and 410. The question is, what does that mean? Okay, this means x we plugged in for t, which was time, right? T is time, and y is the height. So that means that my time is 5 seconds, and my height is 410 feet. Final answer. For your homework today, you need to do lesson 89, A through J, and 2 through 12. It will be due whenever you come to class on Monday. And Monday you'll have your last lesson, so you only have one more textbook lesson to go for the year. I hope you have a good rest of the day.